faster than the fabric of space-time can. If you don't keep up, it will just rip me apart. Terrified by this at the moment, the sky is rapidly changing, and in just a matter of years, if not decades, it may become completely unrecognizable. All over the world, astronomers are hearing the alarm. Specialists such as deGrasse Tyson have recently announced that Polaris's explosion, and the story behind Polaris is quite frightful, and it is known as, long ago, the North Star remained, constant in the night sky, serving as an important reference point for stargazers, astronomers, and navigators. But this might soon change, altering our night sky and astronomical measurements forever. Let's investigate the significance and impact of this threat, implications for each and every one of us, and uncover the story of Polaris as it approaches its end. For centuries, Polaris has aided astronomers and mariners alike, holding a revered position as a guiding light. Its unwavering presence in the sky at night has been crucial for navigation, but soon this stability may be thrown off track. In September 2023, a research paper presented by a respected Royal Astronomical Society cast doubt on the fate of this star of the night. Polaris is about to burst into flames, potentially vanishing from the night sky forever. Before we explore the consequences of this revelation, let's learn more about Polaris, which is also known as the North Star or Pole Star. Polaris is special due to its proximity to the celestial North Pole, almost directly above Earth's North Pole it appears to be almost still in the constellation's northern sky, Ursa Minor, or the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, which is a lot bigger and brighter than our Sun. It's not a solitary star, but part of a complex system of 3 stars, with Polaris A and Polaris B forming a binary pair, while Polaris B orbits around them. The interactions among these stars create forces of gravity that shape their behavior, influencing their orbits. Any changes that occur in these interactions can lead to irregular variations in the patterns of the star's brightness or pulsation. However, the exact mechanisms behind these interactions remain unclear. Polaris is about 323 light-years away from Earth, meaning the light we see from it today started its journey over 3 centuries ago. Thus, if Polaris exploded now, we wouldn't be affected for over 3 centuries later. It's even possible that Polaris has already exploded, and we're yet to observe the light produced by that event. Throughout history, the North Star has possessed significant cultural, navigational, and symbolic significance due to its stability and due to its fixed position. It was of great assistance for ancient navigators, guiding them across land and sea. In a symbolic way, Polaris represented constancy and guidance, remaining unwavering throughout the ever-changing night sky. For astronomers, Polaris served as a crucial reference point that aids in the study of space and time, motions in variable stars. As a Q-fied, periodic changes in the variable star's brightness have been of great assistance, providing insights into the properties of stars and the nature of variable stars. This additionally played a significant role in determining cosmic distances and calibrating instruments. These pulsations adhere to a pattern that is established and has been the norm for the star, making it easy for us to predict how it will act. However, recently, Polaris has strayed from this expected behavior. Its pulsation cycle is irregular and has puzzled astronomers, leading to a closer examination of this celestial anomaly. Instead of its usual predictable pattern, Polaris is now showing erratic cycles of dimming and brightening. Scientists are now raising concerns that the star may be approaching the end of its life. This aligns with behaviors typically observed in stars nearing their end, such as the gradual elongation of the pulsation period of Polaris, which was once stable. This can be attributed to interactions between the stars in its system. We have observed a yearly rise in the pulsation duration of 4.5 seconds, which might seem insignificant, but holds important repercussions. Some astronomers think gravitational interactions among the stars with Polaris's phases could be causing these fluctuations in its specific atmospheric conditions, affecting its pulsation patterns. However, others are more worried because they think that resemblances between Polaris and Betelgeuse, the star on the brink of exploding. The similarities between Polaris's behavior and that of another notable participant in the Orion constellation have demonstrated perplexing diffractions in the light they emit. causing concern about the possibility of explosions in stars at sunset. These kinds of irregularities are common in stages before they reach the end of their life cycles. Despite NASA's statements, heightened anxiety regarding Betelgeuse. Similar attention has not officially been directed toward Polaris, but as a Kifid star nears the end of its life cycle, it progresses through various phases, including the main sequence phase, red giant phase, and ultimately the supernova explosion. Based on Polaris's irregular pulsations, scientists anticipated entered the stages of helium depletion, typical of Kifid stars as they get closer to their end. These irregularities in Polaris's behavior follow predictable patterns of Kifid stars in their twilight phases, but definitive indications of its nearing supernova remain inconclusive. Astronomers are focusing their attention on these anomalies to comprehend what would happen to Polaris if it went supernova. It probably would be a spectacular event that could occur in our skies, becoming one of the brightest things that can be seen for days, a few weeks, or even a few months, significantly altering, temporarily, our perception of familiar constellations like the Big Dipper or Ursa Minor, which includes Polaris. You can rest assured that the Earth is most likely perfectly safe, even if Polaris were to explode because of its size and distance from us, whereas an explosion caused by Polaris might be as visually stunning as that of Betelgeuse. It might still be visible to the naked eye for a considerable amount of time and outshine nearby stars. Astronomers and observatories would unquestionably take notice, and the community of scientists and astronomers from all over the world would observe. The specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What will become of it following a possible supernova explosion? Let's clarify something. Whereas massive stars typically end their lives with a supernova, this is unlikely to be the case for Polaris. When a massive star goes supernova, it explodes massively within, indicating the final catastrophic phase. In its life, this procedure calls for a complete core collapse, resulting in a powerful shockwave that causes the star to violently explode. But Polaris is too big to pass through such a deluge. Instead, if Polaris runs out of nuclear fuel, it will shed its outermost layers and become a white dwarf. This change will not result in a supernova, but rather a peaceful conclusion, as it transforms into a tiny, extremely dense remnant of a star called a white dwarf. A white dwarf is the surviving portion of a low or medium-sized star that has used up its nuclear fuel. It has a very high density, about as big as the Sun, but smaller than Earth's size. When this occurs, we won't be able to see its remnants. From our planet, similar to how we observe the star right now, comparing the anticipated effects of Polaris's burst with the occurrence of supernova in the past provides useful information about the ... The formation of stars and their final fate, contrasting our hopes with well-documented supernova like SN 1054 or SN 1987A. One more recent occurrences like 2011 SN Fe or SN 204 J provides useful information for comprehending the potential outcomes of Polaris's anticipated burst. SN 1054, for example, resulted in the formation of the Crab Nebula that never stops growing and spreads radiation across numerous wavelengths. This provides astronomers with a wealth of study material. Similarly, SN 1987A, discovered in the massive Magellanic Cloud, offered vital information about nucleosynthesis processes, analyzing the dynamics of supernova remnants phenomena like the development of nebulae, the release of cosmic rays, and variations in brightness can provide insights into the specific characteristics of nebula formation. The Crab Nebula, for instance, results from material expelled during the supernova explosion, which then interacts with interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Additionally, the release of high-energy cosmic ray particles accelerated by supernova shockwaves has implications for astrophysical processes in environments contaminated by cosmic radiation. Scientists should make a definitive comparison and examine differences in the composition and mass as well as the rate at which materials are ejected from Polaris's anticipated burst and other observed events. This necessitates investigating the spectra and light curves from these events and projecting similar characteristics for Polaris. Assessing whether Polaris's burst might lead to nebula formation or a distinct outcome can be enhanced by analyzing elemental distributions. Another important area of research involves considering the rotational behavior and decreasing variability stages in stars akin to Polaris against those of known supernova precursors. This comparative analysis can help gauge similarities or deviations and offer insights into the burst mechanisms. Variability in the pulsation of stars nearing the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Despite meticulous observations and extensive analysis, astronomers remain perplexed by the unpredictability of Polaris's behavior, uncovering the one-of-a-kind conditions driving these irregularities holds the key to advancing our understanding of stellar evolution. Understanding the mechanisms responsible for Polaris's irregular pulsations requires interdisciplinary collaboration and the development of sophisticated theories, observations, and modeling techniques. The possibility of losing Polaris as a crucial reference point in the night sky poses substantial concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require new calibrations, affecting the accuracy of astronomical assessments. The absence of Polaris may also impact navigation systems and cultural practices that rely on celestial landmarks, highlighting the significance of this celestial event. The enigmatic behavior exhibited by deGrasse Polaris emphasizes the importance of monitoring stellar phenomena and encouraging collaboration to answer enduring questions about stellar evolution. Polaris's future remains uncertain, but it serves as a powerful reminder of the ever-changing nature of our universe. Even though its final fate remains shrouded in mystery, the study of stars like Polaris contributes to our comprehension of the universe's vastness and nature's unpredictability. Whether or not we witness the dramatic end of Polaris, its legacy as a guiding light will undoubtedly leave a lasting impression on human history and our exploration of the stars. As scientists continue to monitor Polaris, they are also working on new techniques for anticipating and understanding the behaviors of stars nearing the end of their lifespans. The ultimate objective is to improve our understanding of stellar evolution and the numerous possible paths that stars take as they age, including enhancing our ability to foresee cosmic events such as Chauffourne. An investigation of Polaris's irregularities adds an important piece to the puzzle, offering new insights into stellar behavior and the final stages of development. In the context of our solar system and the broader universe, the outcome of Polaris's fate impacts how we view the cosmos as a whole. The stars that light up the night sky are far more transient than many of us realize. Though Polaris may appear to be a constant light, it is, in fact, just one of countless stars each on its own journey. Whether Polaris fades quietly into a white dwarf or ends in a massive explosion, its trajectory reflects the life cycle of many other stars across the universe. In a sense, our own story is mirrored in Polaris, our curiosity, our quest for knowledge. As we gaze up at the night sky, we often search for constancy, for something to anchor us in a chaotic world. But the universe is far more dynamic than we can ever fully comprehend. Stars like Polaris remind us that even the most stable aspects of our sky are constantly evolving, changing, and eventually disappearing. For the time being, as astronomers continue to gather data and refine their models, we may have to wait to witness the end of Polaris. It could be years or even centuries before the true nature of the star's death is revealed. But rest assured, the scientific community will keep a close watch. Whether Polaris fades quietly or explodes spectacularly, its final chapter will leave a lasting impression on our understanding of the universe and the forces that govern it, even if we do not live to witness the end of the North Star. The legacy of Polaris will undoubtedly continue to inspire generations of scientists, stargazers, and dreamers. Whether it fades from view or bursts into brilliance, Polaris has already secured its place in the history of astronomy, a point of reference for countless travelers over the centuries, a symbol of permanence in a constantly shifting sky. The future of Polaris may be uncertain, but its role in our story is indisputable. As we look to the stars and wonder about the mysteries they hold, we can only imagine what discoveries await us next. The universe, vast and mysterious as it is, will continue to reveal its secrets, one star at a time.